Hello, ladies and gentlemen. I would like to present you our work. The work is Monolingual and Cross-Lingual knowledge transfer for topic classification. The first part of our work is making the dataset which is suitable for the knowledge transfer research. We have taken this decision due to the following problems of other datasets. First of all, in most of the other topical datasets, data are not in Russian. At the same time, we wanted to explore the knowledge transfer from Russian language, as the body of work lacks studies on the knowledge transfer from Russian language. Also, in most of the topical datasets, examples are pretty long as they consist of news articles. However, real world conversational utterances are usually much shorter than news articles, which can lead to the suboptimal or subpar performance of the models trained only on the long news-like examples. Also, many topical datasets have too few topics, and even the supported topics often are too specific and don't even remotely cover a wide range of the conversational topics. Also, some topical datasets are few short and lack diversity, which also doesn't suit as well. So we have made the Urku topics dataset. We have constructed this dataset from the data of the Yandex.U servers, which were already publicly available on the Hugging Face. From this data, we have selected 76 conversational topics based on the need of the DREAM dialog system. In our work, we have explored the knowledge transfer on the 6 classes from this dataset, as these classes, examples from these classes can be directly mapped to the corresponding massive classes. I will talk about it a bit later. Most of the examples in the Urku datasets are single label, more than 361,000. However, a significant number is multi-label, a bit less than 171,000. Most of the examples are answered, however, some are not. Example in this dataset means a question with the topics among these 76 ones to which this question belongs. This question matches two answers, and every answer can be also met in any of the 76 topics. A question can belong to more than one topic and answer also. The single label parts are parts where question belongs to one and only one topic. A part where the answer to this question also belongs to one and only one topic. The same topic is a matched part of this dataset. Questions in this dataset are short. Most of the questions have less than 10 words, and only less than 1% have more than 30 words. It's natural for the conversational utterances. However, answers in this dataset are pretty long. Only about 1% of answers have less than 10 words. About 50% of answers have less than 65 words. And about 92% of answers have less than 256 words. I would like to say a couple of words about the DREAM dialog systems, as we have kept its needs in mind while constructing this dataset. The crucial feature of this system, which makes a difference, is that every user utterance that this system takes needs to be annotated. And every hypothesis, every possible answer of this system proposed by this system needs to be post-annotated. And for annotation and post-annotation, topic classification is crucial. For more details, we can refer to our previous article about the dream dialog system. Also, I would like to say a couple of words about the massive dataset. It's a parallel dialog dataset which covers 51 languages. It has about 11.5 thousand training utterances and about 2,000 validation and testing utterances. Every utterance in the dataset belongs to one of the 18 topics. This dataset contains a possible human utterance directed to the Amazon dialog system. And for all languages except for English, this data are the adapted versions of the English data. For example, the English example, turn on the CNN news in the Russian language, it turned into включено новости Первого канала, and so on and so forth. We can refer to the more details about the massive dataset in this article. So there are different possible methods to propose the obtained dataset. We can use only questions, it's mode Q. Only answers, it's mode A. And concatenated questions and answers, concatenated by SEP token, which is Q SEP A. We have tested different backbones. Ru means the Pavlov or bird. Ru's bird means a Russian bird from Sberbank, which is slightly differs from the Pavlov bird. For example, by tokenization mode. Rutiny means two-layer distilled bird from Sberbank. Sorry, from the Pavlov. And mold means monolingual bird base. We have trained all these backbones on the matched data from the Ruku topics dataset, validated on the massive validation set, and tested on the custom test set of massive. Here and further, custom test set of massive is training data and testing data. We only used 6 classes of the Ruku topics that match to massive. And so we used examples only from these classes. 6 classes from training and testing set of massive combined we label as custom test set. These classes are music, cooking, news, transport, weather, and social. We see that Russian only backbones outperform the multilingual backbones on all preprocessing modes. We also see that question only mode performs better than Russian answer only mode, and that concatenated in answer to question, it doesn't yield a sustainable advantage at all. For the full data instead of the matched data, like using not only the matched version, but also absolutely all samples processed by this mode, even the examples which do not contain answers at all, where I would also like to say that in the QSEP-A mode, if there is no answer, it's analogous to the Q mode. We see overall that the results from this table don't change much, like concatenating answer to question where it exists. It doesn't use any significant sustainable advantage. And overall, for large accuracy numbers means that good topics dataset suits well for the conversational topic classification. I would also like to say a couple of words about the metrics of these models on the entire dataset, which is preprocessed by the Q methods. We see that even though metrics expectedly become lower, they still remain fairly high, more than 70%, even for the multilingual task accuracy. It happens even though some classes in the dataset are similar one to another. And still, here are the results, and they stay almost the same for different folds, which means that they are not obtained by chance. Like, let's go almost not obtained by chance, definitely. And any of them, like. A random factor in the false selection wasn't very big, and we contrast these numbers. That's what I have meant. We would also like to examine the knowledge transfer from the Russian language to all languages from Massive. We have trained the multilingual BERT on the full Urku topics 6-class subset question only, validated as in the previous cases on the validation massive subset, and tested on the massive custom test set. We see that the knowledge is being transferred from the Russian language very well. However, what's interesting is the determinants of this transfer. What does it impact it, and what does not? Authors of the multilingual BERT base didn't give an original pre-training sample. However, they have written that they train the multilingual BERT base on the articles from Wikipedia, so on the examples from Wikipedia, and while selecting the examples, the probability was weighted by the factor of 0.7 to make languages appear more frequently. So, even though the number of articles in Wikipedia for every language does not really, sorry, it is not really equivalent to the number of pre-training examples for this language, because articles can have a different length, and because they can be differently tokenized depending on languages, but still we have approximated the number of training samples for every language by the number of Wikipedia articles at the time of the BERT release, exponentiated by the factor of 0.7. We also have computed genealogical distance to the original language, I mean Russian, for all languages. We could. The only language for which we didn't calculate this distance is Malay. However, it didn't change much the calculation, and overall I see that Malay language is pretty similar to Russian. So the correlation between accuracy for every language and approximated size of the pre-training sample of the multilingual BERT for that language is 0.773 with a pretty low p-value. It means that the accuracy by language highly correlates with the pre-training sample size. However, we also have seen the correlation between accuracy and genealogical distance to Russians. It's minus 0.323 with p-value of 2.2 minus 2. However, while we calculate this correlation while taking pre-training size into account, like partial correlation between accuracy and genealogical distance, we see that p-value rises to 0.3, and the correlation becomes smaller by more than two times. So the correlation becomes much smaller, and it becomes not statistically significant. To sum up, Urku-Topka's dataset that we have constructed has large number of classes and training samples. This dataset suits well for the conversation topic classification and for the knowledge transfer research, as different Russian models yield 6-class massive accuracy of about 85% and 76-class 5-fold accuracy of more than 70%. Also, knowledge transfer between languages in the BERT-like models is strongly determined by the pre-training sample size, and it's not determined by the closeness of language to the original language. At least we have felt to see statistical significant correlation between the accuracy by language and the closeness to the original language after taking the pre-training sample size into account. So, thanks for your attention. We have finished. It's over.